In a major advancement in the field of quantum physics, a team of researchers from Italy's National Research Council, CNR, has successfully achieved something unprecedented, transforming light into a supersolid, a rare and exotic state of matter. This breakthrough opens new avenues for understanding the behavior of matter under extreme conditions and developing innovative quantum technologies. "We have effectively transformed light into a solid. It's truly extraordinary," said Dimitrios Trypogeorgos, one of the lead researchers behind the discovery. The work builds upon research initiated over a decade ago by Daniele Sanvito, also from the CNR, who had previously demonstrated that light could behave like a fluid. Today, this line of research has reached a new milestone with the creation of a quantum supersolid made from light. What is a supersolid? A supersolid is a highly unusual quantum state of matter that exhibits a combination of seemingly contradictory properties. It maintains the ordered, rigid structure of a solid while flowing without resistance like a superfluid. In other words, it behaves as a crystalline structure that can also move freely, a property that defies classical physical intuition. These materials exist solely under quantum conditions and, until now, had only been observed in carefully controlled experiments with ultra-cold atoms near absolute zero. A novel approach: light instead of atoms. What makes the Italian experiment groundbreaking is its novel methodology. Instead of using ultra-cold atoms, the team employed a semiconductor composed of gallium and aluminum arsenide, engineered with nanoscale ridges. A laser beam was directed onto this structured material, giving rise to hybrid particles known as polaritons, which emerge from the interaction between photons, light, and excitations within the semiconductor. The ridge-patterned structure played a critical role by restricting the motion of the polaritons and defining their energy levels, ultimately enabling them to self-organize into a supersolid state. This achievement marks the first time a supersolid state has been created using light rather than traditional matter. Experimental confirmation and technical challenges confirming the nature of this new state of matter was no simple task. The researchers needed to precisely measure multiple physical properties of the system to verify that it simultaneously exhibited solid-like structural order and superfluid-like behavior, specifically the absence of viscosity. A supersolid made of light had never been experimentally realized or validated before, said Sanvito, emphasizing the complexity and novelty of their findings. Recognition from the scientific community. The significance of the discovery has also been acknowledged by the international scientific community. Alberto Bramati from Sorbonne University in France highlighted that this experiment contributes to a deeper understanding of quantum phase transitions, phenomena where matter changes state in non-traditional ways. However, he noted that further measurements and analysis are still required to fully understand the properties and implications of this new material, future prospects and applications. According to Trypogeorgos, supersolids based on light could offer greater experimental accessibility and control compared to those created from ultra-cold atoms. This makes them ideal candidates for further exploration of exotic quantum states, with promising potential applications in quantum computing, advanced sensing, and the development of materials with novel quantum properties. A ENW chapter in condensed matter physics. The realization of a supersolid made of light marks the beginning of a new chapter in quantum physics. It not only showcases the ingenuity of Italian researchers, but also opens a frontier full of unanswered questions. With much still to explore, the light-based supersolid stands as a fertile ground for future discoveries and, possibly, transformative technological advancements in the years ahead.